In this video, we'll be discussing factorial notation. Products of consecutive positive integers occur quite often in sequences. These products can be expressed using special notation. If n is a positive integer, the notation n with an exclamation point after it, which is read n factorial, so the exclamation point is factorial, is the product of all positive integers from n down through 1. So n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to 321. Also note that 0 factorial is equal to 1. Let's evaluate some expressions in a factorial notation. In the numerator here, I have 10 factorial. So that means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then we have 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And lastly, 2 factorial, also in the denominator, and these two are smashed next to each other, so we know we're implying multiplication here, so times 2 times 1. And we certainly don't want to figure out what these giant numbers are and then try to simplify that fraction, so we're going to start canceling. 8, 7, 6, 5, 4, 3, 2, and 1. So this is a lot more manageable. We are left with 10 times 9 on the top and 2 times 1 on the bottom. 90 over 2, and we get 45. So another way that we can do this once we get comfortable with the notation, so we don't have to write out like so many huge numbers, 10's not even that big of a number, is I could have done this problem by saying because I see the 8 in the denominator, I could have said that 10 factorial is 10 times 9 times 8 factorial, because I know that 8 factorial takes care of 8, 7, 6, 5, 4, 3, 2, 1. And then just cancel those 8 factorials. So that would have left me with 90 over 2 factorial, which is 2 times 1, still getting us the 45. So once you're comfortable with the notation, maybe you can use this shortcut instead of writing out all the numbers. Our next expression is n factorial divided by n minus 1 factorial. We'll take a look at our definition of n factorial right here. Notice that this part on is n minus 1 factorial. So this would be a great one to use that shortcut for. N factorial is equal to n times n minus 1 factorial. And then we can just cancel those n minus 1 factorials without having to write so much stuff out. This simplifies down to just being n. So that works when we're dividing. If it's any other operation, we got to just write it out and do the factorial. Okay, so we have 5 factorial minus 4 factorial. I'd probably do the smaller number first, because once I get 4 factorial, I just have to multiply that answer by 5 to get 5 factorial. So 4 factorial, that's 4 times 3 times 2 times 1. We got 12 times 2, 24. So 5 factorial is just going to be 5 times 4 factorial, which is 120. So we're going to take 120, subtract 24, and get an answer of 96. Now that we understand factorial notation, let's use it to help us find the first 4 terms of a sequence. Notice that this is not written in a recursion formula. Everything's going to be based off of n here. So a sub 1, that's going to be 20 divided by 1 plus 1 factorial. 20 divided by 2 factorial, and we know 2 factorial is 2 times 1, so 20 divided by 2, we get 10. A sub 2, that's going to be 20 divided by 2 plus 1 factorial. It's 20 divided by 3 factorial. 20 divided by 3 times 2 times 1. That's 20 over 6, which simplifies to 10/3. A sub 3, 20 divided by 3 plus 1 factorial. That's 20 over 4 factorial. 4 times 3 times 2 times 1. We could steal that answer from up above, right? We already found 4 factorial. So 20 over 24, which simplifies to 5/6. And then lastly, a sub 4. 20 divided by 4 plus 1 factorial. It's 20 divided by 5 factorial. It's going to be 20 divided by 120. This will simplify down to 1/6. So here are the first 4 terms of our sequence that was defined using factorial notation.